I welcome you all to the Spark Research YouTube channel. This is Dr. Virchandra, Assistant Professor in the Department of ECE. And if you are preparing for GATE 2027, then definitely these sessions will be very helpful for you. And let me tell you, we are actually talking about the questions which has been asked in GATE 2026. Not only talking about the detailed analysis along with the solutions of the questions which has asked in GATE 2026, but also we will look into the basic idea about that particular topic, so that even if you are very new to here, you will able to understand the solutions from the depth, from the scratch, from the zero itself, right? So that is why these sessions may be the very helpful if you are preparing for GATE 2027, right? Your GATE organizing your 2026 GATE organizing by IIT Guwahati, and this is the 11th session. Before that we have already covered the 10 sessions. So if you want to see all the remaining sessions, I will drop this the link in the description section. You may check it. In this session we are going to take the questions from this particular course, signal and system, and in this session the topic of your question is closely related to the basic of the signal properties, right? So here is the syllabus for this network and the signal system. So here you can see the signal system is there. So property definition and properties are there. So for your signals, right, system. So we will look into the question which is related to these very basics. Okay, so let's take the question now. So question is, consider a real signal xt. Xt is a real signal which is defined in between minus infinity to infinity, such that xt is equal to 0, right? So xt is given is equal to 0 in between t less than 0. So suppose here is your t axis and amplitude axis. Suppose here is your x of t or amplitude axis, right? So it is given that here it is 0, means in this area t less than 0 means there is no values. X of t is equal to 0. Then x of t is equal to how much? 2. Whenever it is in between 0 to 1. So suppose this is your 1. So in between 0 to 1 values are how much? 2. So this is given. Then x of t is equal to 0 for t greater than 0. Again here this is in this region, again this is 0 only, right? So this is the actually the x of t, the graph is given, right? From here only you can extract this graph. Now let xt is the energy, that is minus infinity to infinity x of t all square dt. This is nothing, this is just a formula which can be used to calculate the energy of any signal. So this is nothing, okay? Which of the following option correctly represents the ratio? So you have to find energy of x of t divided by energy of 3 of x of minus 3t plus 5. So you have to shift the same signal xt by 5, and the in the time domain you are going to multiply by 3, and so amplitude again it will be multiplied by 3. So amplitude amplification, so means same signal, just modifications, and then find out the energy and then take the ratio. That's all. So basically question is only find out the energy for the two different signals. That's all, right? So as per answer key, your answer C is correct. So C is the 1 by 3. So let's see how to solve. So first of all, your x of t, right? X of t is equal to 0. What it has already been given in the question, and 2 for in between 0 to 1, and 0 again for t greater than 0. So first find out the energy. So energy, how will you find out for any signal? So this is very simple formula, x of t all square dt, and integrate it over minus infinity to infinity. And also we will find out this one. Actually this is the question also, right? So these three things are given, and two things are given, and third one is asking. So let's find out the energy. So first energy you can find out. So here since signal is your xt is equal to 2 only, amplitude 2 only in between 0 to 1. So remaining are 0. So 0 to 1, and amplitude is 2. So 2 square xt is how much? 2. So 2 square dt. So finally it will be 4. So energy for your x of t is how much? 4. That we got it from here. Right. Now we have to get, like, we got the numerator. Now our objective is to find out the denominator. So first use the scaling properties, and in order to find out the denominator energy, right? So yt is equal to what? Yt is equal to 3 of x and minus 3t plus 5, right? So like you can also write like that a of x into at plus b. So in that case, if you want to find the energy, then how will you find out the energy? So amplitude square and divided by the amplification in the time domain, right? So it will be in the dividing in position, and the remaining e of x is as usual. And why is this in dividing position? So we will look into the details of this the after the one more slide, so you can continue with it. So after putting these values, a and a, the amplitude is given, that is 3, and then time multiplication is also minus 3. So put the values and you will get the energy of this particular e of x of 3 of x at 3 minus 3t plus 5, that will be equal to how much? 12. So just take the ratio 4 by 12. So answer is your 1 by 3. So more detail you can see here. This is the question already been given here, and energy, this is the technique to find out the energy. And for your yt ax plus at plus b, how will you find energy? So amplitude square divided by the time modifications and the ex. So use this technique to find out the energy for both. So first of all, for xt energy is how much? We got 4. And whenever you are shifting in the the first time, so here and time you are shifting, so width will be modified, and then for further you will get the energy for your modified in signal, and then take the ratio of that, right? So finally your option C is correct. And energy and power signal, now let's find. So first of all, how to find the energy of any signal? So integrate over the minus infinity to infinity, and take the square, right? Xt magnitude square into the dt, right? So integration of xt magnitude square and dt from integration over minus infinity to infinity, this is the energy. And power is that the you have to divide by the average, that is the 1 by twice of t, the time period, right? T is your time period. And if your energy, once you will calculate using this formula, if energy is finite, like 1 2 3 4 or any numbers, then this will called as a energy signal. And in this case, if you will calculate the power for energy signals, then it will be 0, right? And similarly for power signals, you can calculate the power, that is 1 by twice t, and integration from your particular time period only, minus t to xt square dt. Here we are taking average, right? So power is the average and energy is total, right? So 1 by twice t, and calculate it and check whether power is finite. If power is finite, that is called the power signal, and in that case energy will be infinite. So very simple, if power is finite, that is called power signal, and if energy is finite, that is called energy signal. And how to calculate energy and power for any xt? So energy you can calculate xt square and dt, and power, calculate that energy over the particular only time period and divide by that time period 1 by twice of t, that you will get the power, right, for that particular signal. Here I think we'll see the example here. So energy, for energy signal, energy is in between 0 to infinity and power is 0. And for power signal, your energy is infinity and power is finite, right? Example is your decaying exponential function is an example of your uh, energy signal. So you can calculate this. This will give the finite value of energy, and power is the power is 0 because the time period is not there, right? And similarly your signal, the sinusoidal or any cosinusoidal, all are the example of the power signal. Why is it so? Because time period is suppose 0 to twice pi for sinusoidal or cosine function, 0 to twice pi. If you will the absorb the power for this only one time period, then it will be finite, right, for only one time period. not, and energy is for entire time period, so that is infinite, right? So in this case, if power is finite and energy is infinite. The signals in upcoming session. Now let's move to the different properties. Now, how can we deal with the different signals? So first, you may require to shift the the signals in time domain. Right? Time domain means on x-axis. So suppose this is your x of t, one signal, one type of the signals, and we want to get it the time delay, right? So time delay, that is x of t minus t naught. So this will be shifting, right? Shifting towards right. Why is it so? Because t minus t naught equal to 0, then t will be equal to the t naught. So by the amount of this t naught, we are going to shift this graph in right side. Similarly, if the time advance, that is xt plus t naught, that is t, we have t equal to minus t naught, so we will shift left, right? So that is also called the advance. So here you can see this is x of t minus t naught. So we are going to seek, suppose this is the origin and y-axis. In this case, what is happening? Our graph is shifting right. So t minus t naught, and t plus t naught means here we are going to shift the left. Actually, this is minus t naught, so that is why this is left. So graph, the y-axis is shifting here. So this way you can the shift in the. Similarly, we'll have one more operation, that is time scaling, that is multiplication in with the time, right? So suppose this is x of t, and now if you are multiplying 2 with the time, then what will happen here? Now on the time axis it will be shifted left, and the it will more closer now, because at t is equal to half only you will get this much of amplitude, right? So your your graph is the compressing. Whenever you will multiply with numbers greater than 1, then your graph will compress, and similarly if you will multiply lesser than 1, then your graph will expand, right, on the x-axis, or that is on the time axis. As for example, here if a is greater than equal to 1, then what is happening here? Since here if it is 1 greater than 1, then compressing, and it will be stressed if it is less than equal to 1, right? So this is the time scaling. You can try to put some values and then you can do it, right? Amplitude scaling, that is on the y-axis. Time scaling means on the x-axis, and amplitude scaling means on the y-axis. So this is very simple. A of yt is equal to a of xt. Simply multiply in the amplitude. So if a is greater than equal to 0, you are going to the advance, that is it will be increased in the amplitude. However, if you are going to multiply in between 0 to 1, then what will happen? The amplitude will shrink, right? So it will decrease. And similarly, if it is minus 1, definitely it will reverse on along the y-axis. So again, mirror image. So depending on the value of the amplification, that is a. So amplitude scaling is also called the amplification. So simply this will give you the the variation on the value of the y-axis. Okay. So thank you to join the session. So play today, stay healthy tomorrow, and learn for a lifetime. Thank you.